In this lesson, we're going to learn how to solve a quadratic equation using the quadratic formula. The quadratic formula can be used to solve any quadratic equation. You want your equation to be in standard form, so it will be ax squared plus bx plus c equals 0. A will be your leading coefficient of your quadratic term. B will be the coefficient of the linear term, and c will be the constant. And the solutions will be given by the formula x equals opposite b plus or minus, that plus or minus gives us our two solutions, square root of b squared minus 4ac all over 2a. So we will fill in the a, b, and c into the formula appropriately and then simplify. So let's look at example 1. In example 1, I see that my equation is currently equal to negative 21. So I need to make the equation equal to 0 by adding 21 to both sides of the equation. So that will give me x squared minus 10x plus, oops, I didn't make that a 21, equals 0. The value of a will be the leading coefficient, which is an understood 1. And so that's what we will substitute for every a in the equation. The value of b will be negative 10, and we will substitute negative 10 for every b in the equation. And finally, the constant is c, which is 21. X equals, make yourself a big fraction bar, and then we're going to start with negative 10. Remember that a is 1, b is negative 10, and c is 21. So the opposite of negative 10 plus or minus the square root of negative 10 squared minus 4 times a times c all over 2a. Notice an important detail here. When I substituted this negative 10 squared, I used parentheses around that negative. It is important that you do that when you substitute this into your calculator, or you need to make note that a negative number squared is positive. If your calculator gives you a negative 100, you have entered that into your calculator incorrectly. You do have to use the order of operations here. A negative times a negative is a positive. Sometimes I just go ahead and write it down as 100 when I plug it in. Now we're going to simplify, and the first thing we want to do when we simplify is square that b term and find out what is underneath the radical. This is called the discriminant. So we want to find that number, but don't put the radical itself into your calculator. Just evaluate the numbers inside the radical. So 10 squared is 100, and 100 minus 4 times 1 times 21 should give me 16. So inside the radical, I have 16. So that gives me, now I have a positive 10, because negative times negative is positive, plus or minus the square root of 16 all over 2. Now, of course, I can take the square root of 16 and make that a 4. So I have 10 plus or minus 4 all over 2. And now to find my two solutions, I'll do 10 plus 4 over 2, and I'll do 10 minus 4 over 2. 10 plus 4 is 14, divided by 2 is 7. 10 minus 4 is 6, divided by 2 is 3. So my two solutions for this problem, or this equation, are 3 and 7. Now, this particular problem, you'll notice we got integer solutions. If you get integer, or just really any rational solution, it's likely that you could have solved the equation by factoring to start with. And so if you look at the method for factoring this same problem, x squared minus 10x plus 21 equals 0, we need to find two factors of 21 that add up to negative 10. Two factors of 21 that add up to negative 10. We could try 1 and 21. They both need to be negative to give us a positive result for the product, and a negative sum. That adds up to negative 22. So then I'll try 2, doesn't go into 21, but 3 does. And negative 3 and negative 7 gives me negative 10. So I've got x minus 3 and x minus 7. And that was a lot quicker than plugging into the quadratic formula, because my solutions are positive 3 and positive 7 when we add the 3 to the other side, and we add the 7. So if you were given a choice between factoring or using the quadratic formula, you could choose whichever one seemed easier if you were given the choice. But this just shows you that even when you could have factored the problem, the quadratic formula will yield the same result. Now let's look at example 2. In example 2, the equation is already equal to 0 and given in standard form. So I'm ready to substitute. The value of A is that understood coefficient of 1. The value of B is 6, and the value of C is 9. So now we'll substitute. X equals -6 plus or minus, make yourself a big square root symbol, B squared minus 4 times A times C all over 2A. Now we're ready to evaluate the number underneath the radical. That's the discriminant, and that's 36 minus 36. That gives me 0 inside the radical. So that gives me -6 plus or minus the square root of 0 over 2. And I do encourage you to practice with your calculator and make sure that you're getting the same thing I'm getting when you substitute these things into your calculator, because you don't want to make those calculator mistakes on test day. So the square root of 0 is 0. So we really have nothing to add or subtract here with our plus or minus. What that's going to mean is that when we end up trying to add 0 and subtract 0, we end up with the same result twice. And this is what's known as a double root. So we have -6 plus or minus 0 divided by 2. And when I go to do my plus or minus, -6 plus 0 is -6 divided by 2, which is -3. And then -6 minus 0 is -6 divided by 2, which is also -3. So we got the same answer twice. So this equation has what is known as a double root, the same answer twice. So for this one, let's work this one out using the square root property. The square root property is where we try to get a quantity or a variable squared on one side of the equation and constants on the other side so that we can take the square root. We have x squared plus 6x plus 9 equals 0. And I don't know if you noticed, but this is a perfect square trinomial. This is x times x, and this is 3 times 3. And the sum of these two add up to the middle of 6. 3x plus 3x is 6x. That's a perfect square trinomial. So that can be factored into x plus 3 quantity squared equals 0. So now in order to solve this, I can take the square root of both sides. That square power eliminates the square root so that we get x plus 3 equals 0. Don't forget your plus or minus, but in this case that plus or minus is somewhat irrelevant because it's on a 0. And then we're going to subtract 3 to the other side, which gives us -3 plus or minus 0. Once again, -3 plus 0 and -3 minus 0 give us the same result twice, and the solution is -3, a double root. One unique solution, two solutions that are identical. Now let's take a look at example 3. This time we're going to use the quadratic formula and compare it to completing the square. So again, this equation is already in standard form, and my coefficients A is 2, B is 8, and C is -6. And those are coming from here, here, and here. And don't forget that the sign in front of a term goes with it. So now we are ready to substitute into the formula. X equals opposite B plus or minus big square root B squared minus 4 times A times C all over 2A. Now we want to simplify what's inside of our radical. So we are going to multiply 8 squared minus 4 times 2 times -6, and that gives us 112 underneath the radical. Again, do not type the radical symbol into your calculator, just find out what value is inside of there. So we have -8 plus or minus the square root of 112 all over 4. Now, we need to simplify the square root of 112 by bringing out a perfect square. So we're going to split 112 into two factors, one of them being a perfect square factor. So don't forget your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. But that should be big enough because remember we're going to start with about half of 112, which maybe 64 is close to half of 112, but it does not go in evenly. So then we'll try 49 and it doesn't. 36 does not. 25 does not, but 16 goes into 112. 16 goes into 112 7 times. So that's going to be 4 radical 7. So we'll simplify that, negative 8 plus or minus 4 radical 7 over 4. And then we have one final step here that we haven't encountered before in this lesson. We have practiced this before when we worked with complex numbers. We need to simplify by dividing all 3 of these coefficients by a common factor. And you are going to do this when they are divisible by a common factor. In this case, that common factor is 4. So we're going to divide all 3 of those coefficients, not the 7 on the inside, but the 8, 4, and 4. And that will give us negative 2 plus or minus radical 7. So again, we're dividing each of these by 4. The negative 8 divided by 4 gave me negative 2. And then 4 divided by 4, and on the top and the bottom, those both became 1s. And so we could write this over 1, but that's not necessary, so that's why I left it off of there. So our first solution will be negative 2 minus radical 7, and our second solution will be negative 2 plus radical 7. So we have irrational solutions here, but that's okay because that gives us a chance to practice with our simplifying radicals and fraction skills. So let's take a look at how this would work out if we solved it by completing the square. So I'm going to use my same equation, 2x squared plus 8x minus 6 equals 0. If we get started on the process of completing the square, we want to eliminate this leading coefficient by dividing every term, including the 0 on the other side. That's why this is legal, because remember, when you're solving equations, it is legal to do the same operation to both sides of the equation, which includes every term of the equation. So that's going to simplify things a little bit for us. So now we have x squared plus 4x minus 3 equals 0, and we're ready to complete the square. So remember, in this process, we want to create a perfect square trinomial using the x squared term and the 4x term. So we want to move the 3 to the other side of the equation. So I'm going to move 3 over by adding it. And now I have x squared plus 4x, and I'm going to leave a space to complete the square here. Bring down your 3 plus 0, and whatever I add to the left-hand side of the equation, I'm also going to add to the right. So this is where we will complete the square by making a perfect square trinomial out of x squared plus 4x plus c, whatever that c might be. And we learned a quick shortcut for that, which is half it, drop it, square it, add it. So we're going to take half of the 4, which is 2. We're going to go ahead and drop it into our parentheses to create that binomial squared factor. We're going to square it, and then we're actually going to square 2, which gives us 4 to add to both sides. Half it, drop it, square it, add it. We're taking half of 4, we're squaring it, and that's what we're adding to both sides of the equation. Half it, drop it in, square it, and add it to both sides. We have 7 on the right-hand side of the equation when we actually go ahead and add these two numbers together. And we are ready to take the square root of both sides. So square root here and square root here will eliminate that square power. So we have x plus 2 equals plus or minus radical 7. Radical 7 does not simplify. It cannot be divided by a perfect square. So now we'll subtract 2 and get x equals negative 2 plus or minus radical 7. which we see is the same solution that we got when we used the quadratic formula. So there's one more unique way that the quadratic formula would turn out. So we're going to do one more example of this. And this next equation is not in standard form. We have 6x on the other side of the equation, so we're going to subtract the 6x term. And I'm going to put it in the middle so that they're in descending power order. So my a will be 1, b will be -6, and c will be 13. So we have the opposite of -6, which is +6. I'll write that down. I'll write opposite of negative just to be clear. Plus or minus, make yourself a big square root symbol. And then we're going to put in our b squared, so -6 squared. Make note, be careful, this is a negative. It should turn out as a +36 when you square it. -4 times a times c all over 2 times a. And again, that negative b value being squared, that's a common error that students make when they're typing it into their calculator quickly. You really need to use those parentheses here with the square on the outside of the parentheses in order to show that you are actually multiplying -6 times -6. When we evaluate -6 squared minus 4 times 1 times 13, we get -16. So that gives us 6 plus or minus square root of -16 over 2. Now, we learned earlier in this unit that if we have the square root of a negative number, we can represent that using I, the imaginary unit. And so we're going to simplify the square root of -16 as 4i. So now I have 6 plus or minus 4i over 2. And then my last step will be I can simplify all of these by dividing by a common factor of 2. So this factor that I'm using, it has to be common amongst all three of these coefficients. And so I will end up with 3 plus or minus 2i over 1, and we don't have to put that 1. So 3 minus 2i and 3 plus 2i are my solutions. So you can see we've had a few different outcomes in these examples. If we had a negative underneath the radical, we ended up with imaginary solutions. And if we had a 0 underneath the radical, we ended up with one unique solution. And then if we had a nice perfect square number underneath the radical, we ended up with two nice, neat, rational solutions. And if we ended up with kind of an ugly number that's not a perfect square, but it's not a negative, then we ended up with two irrational solutions that have radicals in them. So we can use the value of the discriminant to determine the type of solutions that we'll get, because how that radical simplifies is what determines how nice our answers are. So now we're going to take a look at how we can use that discriminant as a shortcut to predict the outcome of our equation. So again, the expression b squared minus 4ac is called the discriminant. And it is the number that lives inside the radical, not after having evaluated with the radical, but just the number that lives in that little house, okay? The value of the discriminant can be used to determine the number and the type of the roots of a quadratic equation. If the value of b squared minus 4ac, again, the number that is inside the radical, is a positive number, then we will have two real roots. And to go a little further with that, if it's a perfect square, then you'll have two nice rational solutions. And if it is not a perfect square, you will have irrational solutions. So rational solutions, let's talk about what that means. That means that you might get an integer or a fraction it could be a decimal, but we don't typically use decimals. We're using fraction answers here in our class, but it could be a fraction. Irrational. What's the difference between irrational versus an integer or a fraction? Irrational means that it cannot be written as a fraction. Usually in this case, that means that it'll have a radical. If your discriminant is 0, remember what happened when we got that 0 inside of our radical? We had nothing to add and subtract with that plus or minus because the value of square root of 0 is 0. And that is why we get one real rational solution or root when we have a 0 inside the radical. Finally, if we have a negative number, for the value of our discriminant, this is when we'll get two complex roots. And remember, complex means that it has an imaginary part with it. And the reason is because if you have a negative inside of your radical, you're going to simplify that using an I. Okay, so those are the types of outcomes that we could have with our quadratic formula problems, and we can use the discriminant to predict the outcome before we even start. Now, here's a cool hint as well. You can test just the discriminant in your calculator, and if it's a perfect square, that means that it could have been factored. So if you hate the quadratic formula and you love factoring, you can plug a, b, and c into the discriminant, b squared minus 4ac, and if it's a perfect square number, backtrack and factor instead of using the quadratic formula. So let's look. It says, look back at examples 1 through 4 and note the discriminant, number, and types of solutions for each. So in example 1, we'll go back really quickly. In example 1, our discriminant was 16. Here it is right here. And that is a positive number, and it's a perfect square. So let's see. We had 16 for our discriminant, which is a positive number. So if we got a positive number, that means we have two solutions, and they are going to be rational solutions, real numbers, and rational solutions because it's a perfect square. Okay, real versus imaginary, which is complex. Okay, so all three of these, or I'm sorry, I guess those two options are going to give you real solutions, and these are going to give you imaginary or complex solutions. Okay, so in example 2, our discriminant, well, that's example 3. Example 2, our discriminant was 0. So when we did that example, we saw that we only got one solution. And in that situation, they're going to be real solutions, and they're going to be rational. In example 3, our discriminant was 112. That is a positive number, so that's going to give us two real solutions, but irrational. Two real solutions, and they would be irrational because that number was not a perfect square, so it left us with a radical in our answer. And then finally, the last one we had was negative 16. It's right here. So for negative 16 inside the radical, that ended up giving us two solutions, but this time they were complex solutions, meaning that they had imaginary answers. So let's look at the last example and use the discriminant to determine the number and type of roots for each equation. So for example 5a, the value of a is 1, the value of b is 3, and the value of c is 5. Again, it does need to be in standard form before you determine these values. I'm going to substitute into b squared minus 4ac. Notice that there is no radical on this expression. It's just whatever number lives inside that radical. Okay? So that's going to be 3 squared minus 4 times 1 times 5. And when I evaluate that, that's 9 minus 20, which is negative 11. So that's a negative value. So that's going to give me two complex solutions. Our next example, we'll do the same thing. A is 1, B equals negative 11, and C is 10. So I'm going to substitute those into B squared minus 4AC. So negative 11, using parentheses, especially important when your value is negative, minus 4 times 1 times 10. This gives me 121 minus 40, which is 81. So last time I got a negative, this time I got a positive number. So I know I'm going to get two real solutions. And 81 is on my lovely list of perfect squares. And so since that is a perfect square, I'm also going to get a nice rational solution. Last one, this one is in standard form. So A is negative 5, B is 8, and C is negative 1. So 8 squared, that's B squared, minus 4 times negative 5 times negative 1. This should give me 64 minus 20, which is 44. So 44 is a positive number, so I should get two real solutions. And it's not a perfect square number, so it's going to be an irrational pair of roots. So when we're working with quadratic equations, we can predict the outcome of the problem by looking at the value of the discriminant, which is the number that lives inside the radical in the quadratic formula. And that is also the first step of solving using the quadratic formula, so oftentimes we're doing that at the beginning anyway. It is helpful to memorize the quadratic formula, and there are some songs out there that you can use to help you do that. I am not a singer, so I am not going to sing those songs for you, but you can find them on YouTube. Good luck!